Good lemonade. Um, my students, Math Mafia. Welcome once again to the Geometry series. Your host Timothy Frazier, Frazier Nation. We out here. We're gonna go into 3.1. Identify pairs of lines and angles. It's really a short section. This might seem like a long video, but this is actually the shorter section out of the three we're about to dive into. So just hold on for the ride. One objective, students will be able to identify angle pairs. Remember, pairs means what? Two pairs of angles formed by three intersecting lines. The essential question is, what angle pairs are formed by transversals? Transversals is a vocab term. You will get to that. Let's review a little bit. When we say perpendicular, that means it intersects at a 90-degree angle. Parallel and skew, they both mean not touching, not intersecting, but there's kind of a difference between the two. Let's see. Lines go on forever in each direction, hence they're having two arrows. So whenever you see a line, it has two arrows. It goes on forever in this direction, goes on forever in this direction. And then coplanar means on the same plane or the same flat surface. So here's a plane, okay? Let's call this plane V. And point A is on the plane, point B is not on the plane, and point C is on the plane. So point A and point C would be coplanar, and points A and B are non-coplanar. Okay, so we just need to remember what those are. Key vocabulary. So when we talk about parallel lines, those are two lines that do not intersect, but they have to be coplanar. They have to be on the same plane. So on your phone screen or your device screen or your computer screen, here are two parallel lines. Okay, they're on the same flat surface, so these are parallel. Okay, skew lines, on the other hand, are lines that don't touch, but they're not on the same plane. Okay, so if you can imagine like one line, on your phone screen and another line coming out of the phone screen, that's going to be non-coplanar. Two parallel planes, if you put like two sheets right next to each other, two sheets of paper, those are two planes that are not going to intersect, hence parallel. And then transversal, and you notice I have a nice little beautiful star here. This is going to be a really important vocab term, so you really want to pay attention to this. A line that intersects two coplanar lines at different points, okay? So I know we wrote the words down. Let's get the pictures. Parallel lines, and I want to point this out. When you have two sets of arrows on lines like this, so here is two sets of arrows, okay? When I have two sets of arrows, these mean parallel, okay? So these red arrows, when I have a set of two arrows on two lines, that means parallel, okay? Skew lines, now notice, line MB is on plane Q, okay? JG is not on plane Q. So MB and JG, they will never touch, but they are not coplanar because JG is not on the plane. So let's write that down. Line JG is not on plane Q. Okay, we just want to make sure that you see that. Okay, it's going through plane Q, but it's not on plane Q. Okay. One thing I didn't say earlier, when we say parallel lines, the symbol is two lines up and down. So down here, I have plane M and plane C. Plane M is parallel to plane C. Okay, and then transversal, I have two lines. Okay, see my two lines, and then the red line. So we would say line T. Line T is a transversal. Okay, you really need to get familiar with this term right here. Okay, vocabulary still. This is the meat and potatoes of this section. Corresponding angles are angles that have corresponding positions. You might say, well, Frazier, what is corresponding? That means matching. Okay, so means matching angles, matching positions. Angles that have matching positions. We'll get you some pictures. Alternate interior angles. These are angles that are inside two lines, interior, inside, on opposite sides of the transversal. So here's your inside, and alternate means opposite. Okay. Okay. Again, alternate means opposite. Exterior means outside. So look at your description. You have two angles that are outside of two lines and on opposite sides of the transversal. Consecutive means same side. Okay, same side, and it's going to be inside. So angles that are inside two angles and on the same side of the transversal. And let's go ahead and get some pictures. So corresponding angles, 1 and 2 are in the same position. Like this one is on top and on top of this line and on the right side of the transversal. This is on top of this line and on the right side. So 1 and 2 are corresponding angles. 3 and 4 is at the bottom and to the left of the transversal. So 3 and 4 are corresponding angles. They have matching positions. Alternate interior angles. So if you look at 1 and 2, they're inside of your two angles, so they're inside, and they're on opposite sides of the transversal. Okay, so opposite, inside, opposite for alternate, exterior. So 1 and 2 are on the outside of these two lines and on opposite sides of the transversal. 1 is on the left, 2 is on the right, 4 is on the left, 3 is on the right. So 3 and 4 alternate exterior, 1 and 2 are alternate exterior. And then consecutive interior, they're on the same side of the transversal. So you got to think consecutive means same side. So 1 and 4 are on the same side of the transversal on the inside. So consecutive interior. And 3 and 2 are on the same side and on the inside. Okay. Let's go ahead and look at some guided practice, But I do want to get two postulates out the way. Parallel postulate and perpendicular postulate. Look at what's going on. Okay, so it says given a line. So here's a line. Okay, here's a line. Let's call it, I don't know. Let's call this line TF. My handwriting is atrocious tonight, and I don't know why. Okay, so let's call this line TF. And so given a line and given a point not on that line, so here's a point right here. There's exactly one line that will go through my point, let's call this point A, that is parallel to TF. Okay, so here's a line. Okay, and I'm saying that this line, there's only one line that will be parallel to TF, so we got to let's put our second set of arrows on here. Okay, so that means that these are parallel. Okay, there's only one line, so I can't draw like more lines through point A that's going to be parallel to TF. Only one line can do that, and that's the line with point A on it. Perpendicular is the same thing, except it meets at a 90-degree angle. So here's a line, and let's call this, I don't know, KB. Okay, and through a point not on that line, so let's call this point E. Okay, the perpendicular postulate says that only one line can go through point E and be perpendicular to it at the same time. Okay, So that means meeting at a right degree angle. There's only one line that can do that. There are other lines that can go through point E. Okay. There's other lines that can go through point E, but they won't meet at a 90 degree angle. Okay. So let's go to our next card. Guided practice. Okay. Look at the diagram. Name the lines through point H. So here's point H. That appear skew. Okay. Skew. If you remember, that means non-coplanar. So that means that you cannot put it on the same plane as CD. Okay, so here's point H. So if CD is going in this direction, HE is not going in that direction. HE and CD cannot be put on the same flat surface. So we could say line, I don't know why I drew a C there. Y'all fault. So let's do line HE. Let's see. Line HA is going up and down. CD is going left and right. So we could do HA. Okay. Let's see. So HE, HA. Okay. What's the problem with HG? Why can we not say HG? Can we say HG? No, we cannot say HG because CD and HG are going in the same direction. Okay. If I put a flat surface across CD and HG, they would be on that flat surface. Okay. So if I put a box or a flat surface on HG and CD, they would be on the same on the same plane. And skew means non-coplanar, so we cannot say HG. HG does not work here. Okay. Number 2. I know it might be hard to see, but I have 2 lines here. Okay, and I have a right degree angle right here. Okay. So just draw your lines, BF, CE. Draw these 2 lines right here. And it says, can you use the perpendicular postulate to show that line AC is not perpendicular to BF and Y? Well, the perpendicular postulate says that one line can go through a point that is not on, what do you call it? Right here. So line AC, okay. So what I was saying was that we have a line MD, okay. It is perpendicular. How do I know that? Because they're meeting at a 90 degree angle. MD and BF are perpendicular. So if I already have my one line that goes through this point and it's perpendicular, the perpendicular postulate says that I can only have one line that does that. And since MD does that, I'm guaranteed that line AC cannot be perpendicular. Okay? So it's because line MD is already perpendicular. And I don't know if y'all remember this line, this little symbol right here. Is already perpendicular to line BF. Okay. Classify the pair of numbered angles. So 1 and 5. So 1 and 5, are they both inside the lines? No. Are they both outside the 2 lines? No. So I'm going to put a T here next to this. This is my transversal. And the only thing that matches 1 and 5 are that they are matching. They're matching in position. So they're both on the left of each line and they're on the right side of each on the transversal. So this has to be corresponding angles. Okay. Okay, right here, 2 and 7. They are both outside my two lines. Here's my transversal right here. Okay, there's my transversal. And they're outside my two lines. And they're on opposite sides of my transversal. This one's on the right, this one's on the left. So I have alternate, okay, because they're on alternate sides of my transversal. And they're on the outside. So it is alternate exterior angles. And then right here, here's my transversal, okay? And then 5 and 4 are on opposite sides of my transversal. So again, that's alternate. Okay, 5 and 4 are on the inside of my two lines. So that's interior. And then, those are my alternate interior angles. Okay, so let's do the homework. Let's ask questions. Let's be merry. And I'll see you next time.